Okay, we want to find the area enclosed by these two graphs. Now this first graph, x equals y minus 2 quantity squared, is a sideways parabola. It looks like this. And y equals 1 half x plus 1 half is a line with the y-intercept of 1 half here, and the slope is 1 half. So it's going to look something kind of like this. So if I continue this out over here, the area that we're trying to find is this inside of here. Now, before I go any further, let me show you how to graph this on a TI graphing calculator. Normally, you graph things where y is a function of x. If you want to graph something where it's solved out for x, there's a trick you can use here. You go to Mode, and down here you change from function to parametric. But once you've done that, quit. When you go to y equals now, notice it has x1 and y1. Down here, for y1, if I press the normal button that I usually use, it gives a t there. So now y and t are equal to each other. So I can make x equal to t minus 2 squared. And so now I've got x equals t minus 2 squared. And that's the same as my graph over here, or my equation. So if I graph this, notice it gives me the parabola. Now, if you don't get the whole parabola, or if you don't get the part of it that you need, you can go into Window and change your t. I've got it starting at -5 and going to 10. If you don't get everything you need, just try expanding that. So anyway, once we've got that, this is the area that we're trying to find. And this is an area that's going to be much easier to find using horizontal rectangles, because if we drew them vertically, then over here the top and bottom would both be on the parabola, and over here, once you get past this point, the top would be on the parabola and the bottom would be on the line. So it's better to draw them sideways. That way, anytime you draw them, no matter where you draw it on inside of this region, one end is going to be on the line, the other end is going to be on the parabola. So we've got to find the area of this thing. Now the area of it, if we look at the thickness, which I've been calling the height, because it's up and down, this is a tiny change in y, so that's dy. Now we also have to find the length of this thing from one end to the other. So what we need is to find this point and this point. Now these 2 points both have the same y coordinate. Yeah, it looks like it's 3 here, but you don't want to put a number in here. We need a formula that will give us the length of a rectangle, whether I draw it here, or here, or here, or anywhere else. So what I need now is I need to talk about the coordinates of this point here and of this point here. You might say, does it matter if it's the top or bottom of the rectangle? And the answer is no, it doesn't matter, because when we do the integral, the number of rectangles goes to infinity, and so they get very thin. So really we just have to look, you can almost think of it as a line, a very thin rectangle, and each end we need to look at the coordinates. Now, since we're doing this with respect to y, the y coordinate of both of these guys is just going to be y. To get the x coordinate, we've got to look at the equations. Now, the parabola on this one's easy because it tells us that the x coordinate in terms of y is y minus 2 quantity squared. For this one over here, we've got to solve this equation out for x. So, because we're looking for the x value. So if I take this, the first thing I do is multiply by 2. So I get 2y is equal to x plus 1. So x is 2y minus 1. So now to get the length of this rectangle, it's going to be the right end minus the left end. So it's going to be 2y minus 1 minus y minus 2 quantity squared. So that's the right side minus the left side. And of course the width or height, whatever you want to call it, is dy. So let's work this out. The length is going to be 2y minus 1 minus, if I square this out, I get y squared minus 4y plus 4. And if I combine this together, I get 2y plus 4y is 6y. Negative 1 minus 4 is negative 5. And then minus y squared. So the area that we're looking for is the integral of the length times the height. So 6y minus 5 minus y squared dy. Now I need to put some endpoints on here. So we come back up here and we look at where do the rectangles start and where do they end. Well, if I were to draw them all in here, we'd have rectangles all the way up. They would start down here and they would end here. So what we need is the y-coordinate of these 2 points here. That's where the parabola and the line cross. So what I'm going to do is I'm going to take the line and plug it in up here into the parabola. Now notice the parabola up here was originally solved out for x, and this is solved out for x here. So to find the crossing point, I'm just going to set them equal to each other. So this is x is 2y plus 2y minus 1. This is x is y minus 2 squared. And I got to solve this. Two y minus 1 is y squared minus 4y plus 4. If I move all this to the other side, I get y squared minus 6y plus 5, and that factors into y minus 5, y minus 1. So I get y is 5 and y is 1. That's the coordinates of this point here. The x-coordinate, we could find it if we wanted to, but it doesn't matter. We're going from 1 to 5. Alright, so let's integrate this. 6y gives us 3y squared minus 5y minus 1/3 y cubed. We're doing that from 1 to 5. So plug in the 5, we get 3 times 25 minus 5 times 5 minus 1/3 of 5 cubed, which is 125. And over here plug in the 1, we get 3 minus 5 minus 1/3. And now I'm just going to do this on my calculator. Well, that's 75 minus 25. Obviously 50. Minus 125 over 3. So this is 25 over 3. Then 3 minus 5 minus 1/3 is negative 7/3. So it's 25 plus 7 is 32 over 3. And that is the area.